Our lesson today is to be able to evaluate the nth root of a number. We want to be able to evaluate expressions with rational exponents. And when we come down here, right, this is really what we're going to be using the most as far as rules go. A to the 1/2 is a number whose square is a. So you can write the square root of a as a to the 1/2. The cube root of a number is that number to the 1/3 power. The fourth root of a number is that number to the 1/4 power, and so on. All right. Let n be an integer greater than 1. Let a be a real number. If n is odd, then a has one real nth root. If n is even and a is greater than 0, then a has two real nth roots. If n is even and a is equal to 0, a has one real nth root. And if n is even and a is less than 0, it has no real nth roots. Essentially, if we're taking the root of a number and that number is greater than 0, it has two real square roots. If a number is equal to 0, then the square root of 0, or any root of 0, is going to be 0. And if we're taking the square root of a negative number, right, that cannot be done, right? So it is not a real number, the square root of a negative number. So let's take a look at some examples here. We want the cube root of 64. Well, in order to find the cube root of 64, we want to know this, right? The cube root of 4 times 4 times 4. 4 times 4 is 16, times 4 is 64. So the cube root of 64 is going to be equal to 4, because 4 is used as a factor 3 times. So the cube root of 64 is going to be 4. For example B, we want the fourth root of 81. So we want to know what number used as a factor 4 times gives us a product of 81. We would write it like this: the fourth root of 3 times 3 times 3 times 3. 3 times 3 is 9, times 3 is 27, times 3 is 81. So the fourth root of 81 is going to be 3. This next example, we want the square root of 400. The square root of 400, we would write this way: the square root of 20 times 20. Right? 20 times 20 is 400. So the square root of 400 is 20. In example B, we want the fifth root of 243. So what number used as a factor 5 times, right? What number used as a factor 5 times would give us a product of 243? So we would write that like this. Oops. We would write it as the fifth root of 3 times 3 times 3 times 3 times 3. If I use 3 as a factor 5 times, I get the product of 243. 3 times 3 is 9, times 3 is 27, times 3 is 81, 81 times 3 is 243. So the fifth root of 243 is going to be 3. All right, we look at our next example. We want to find the nth root of a number, and that root is going to be negative 27. Well, so we're looking at this. We want the cube root of negative 27. So we want to know what factor, or what number used as a factor 3 times gives us a product of negative 27. So that would be the same as the cube root of negative 3 times negative 3 times negative 3. 3 times 3 is 9, times 3 is 27. We have an odd number of negative factors, so that makes it negative 27. So the cube root of negative 27 is going to be equal to negative 3. Example B, we want the fourth root of 16. So what number used as a factor 4 times gives us a product of 16? So that would be the fourth root of 2 times 2 times 2 times 2, because 2 times 2 is 4, times 2 is 8, times 2 is 16. So the fourth root of 16 is going to be equal to 2. All right, we have a couple more examples down here. Example A, we want the cube root of negative 64. So that would look like this, the cube root of negative 64. We want to know what number used as a factor 3 times gives us a product of negative 64. So that would be the same as this, right? Negative 4 times negative 4 times negative 4. 4 times 4 is 16, times 4 is 64. So the cube root of negative 64 is going to be equal to negative 4. And for example B, we want the square root of 81. The square root of 81, we know that that's going to be equal to 9, right? And we're talking about principal square roots here. What does the exponent 1/5 mean in the expression 64 to the 1/5? It means that we want the fifth root of 64, right? We want the fifth root of 64. So what number used as a factor 5 times would give us a product of 64? Is that 2? Let's see. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So right, I don't know what the fifth root of 64 would be, but it's not going to be, you know, an integer value here. But they're just asking, what does that expression mean? And it means we want the fifth root of 64. Find the indicated real nth root of A. So for example 2, we want the square root. Come on. Let's undo that. We want the square root of 400. So that is the square root of 20 times 20. So the square root of 400 is 20. Problem 3, we want the cube root of negative 125. What number used as a factor 3 times gives us a product of negative 125? That's going to be negative 5 times negative 5 times negative 5. So the cube root of negative 125 would be negative 5. For problem 4, we want the sixth root of 64. So what number used as a factor 6 times gives us a product of 64? All right, it's probably 2. Let's see, 2 times 2 times 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So the sixth root of 64 is equal to 2. Next, we want to evaluate expressions with rational exponents. Recall that the radical a indicates the positive square root of a. Similarly, an nth square root of a and an even index indicates the positive nth root of a. All right, so we want to evaluate each of these. So we want the cube root of negative 8. So what number used as a factor 3 times gives us a product of negative 8? So that would be the cube root of negative 2 times negative 2 times negative 2. So the cube root of negative 8 is negative 2. For example B, we want the opposite of the cube root of 8. So we want the opposite of the cube root of 2 times 2 times 2, which would be the opposite of 2, or negative 2. For example C, we want the fourth root of 16. So we want the fourth root of 16. So we want the fourth root of 2 times 2, which is 4, times 2 is 8, times 2 is 16. So the fourth root of 16 is going to be equal to 2. In our last example, we want the fourth root of negative 16. Well, this would be not possible because we cannot have negative numbers do not have even roots. Negative numbers do not have even roots. Don't have even roots. Meaning there's no number that I can multiply an even number of times that would give me a negative product. Right? So this would be, the answer would be not a real number. Not a real number for problem D. Right? So if we take a look at each one of these examples here, the fourth root of 81. Oops. So if I want the fourth root of 81, I want the fourth root of 3 times 3, which is 9, times 3 is 27, times 3 is 81. So the fourth root of 81 is going to be equal to 3. Here I want the opposite of the fourth root of 81. So I want the opposite of the fourth root of 3 times 3 times 3 times 3. So it's going to be the opposite of 3, or negative 3. Here I want the square root of 25. Square root of 25 is going to be equal to the square root of 5 times 5, right, which is 5. And here, once again, I can have the square root of a negative number, right? So this is not a real number, not a real number as far as our answers go. All right, some other examples. Right, we have all this algebra stuff up here. All right, let's take a look at what this means. So here we have 64 to the 3/2 power. Now let's talk about what this means. 64 to the 3/2 power is the same as 64 to the 1/2 times 64 to the 1/2 times 64 to the 1/2. We know from our product of powers rule that when we're multiplying powers to the same base, we simply add the exponents. So 1/2 plus 1/2 plus 1/2 gives us that sum of 3 over 2. So in real terms, we want the square root of 64, which is 8, times 8 times 8, right? Which is 512. Another way of thinking about this number would be this, right? Let's look at it another way. 64 to the 3/2. We want to take the square root of 64, right? I see the denominators too, so let's take the square root of 64, which is 8, and I want the cube root. Oh, I want the cube of that square root. So I want the square root of 64, which is 8, but then I have to use it as a factor 3 times. Right? So that's another way of seeing the 3/2 power. We want the cube root, we want the square root taken as a factor 3 times. So let's look at some examples. All right, so if I'm looking at this first example, example A, 16 to the 3/4 power. 16 to the 3/4 power is the same as 16 to the 1/4 times 16 to the 1/4 times 16 to the 1/4 power. Right? Now what is 16 to the 1/4 power. 16 to the 1/4 power is 2, because 2 times 2 is 4, times 2 is 8, times 2 is 16. So 16, we want the fourth root of 16, which is 2, times 2, times 2. All right, and that's going to be equal to 8. Another way of thinking about it is this. We want the fourth root of 16 used as a factor 3 times. So the fourth root of 16 is 2. I have to use it as a factor 3 times, and that's where I get my product of 8. Problem B, right? Example B. We have 27 to the 4/3 power. That's the same as 27 to the 1/3 times 27 to the 1/3 times 27 to the 1/3 times 27 to the 1/3. Right? Because when we're multiplying powers with the same base, we add the exponents. 1/3 plus 1/3 plus 1/3 plus 1/3 gives us the 4/3 power. Right? So what is the cube root of 27? 3 times 3 is 9, times 3 is 27. That's the same as 3 times 3 times 3 times 3. 3 times 3 is 9, times 3 is 27, times 3 is 81. The other way of thinking about it is this. I want the cube root of 27, which is 3. I have to use that 3 as a factor 4 times. And we get 81. Right? Let's look at these examples here. 243 to the 1/5 power. 243 to the 2/5 power. Right? So that's the same as 243 to the 1/5 power times 243 to the 1/5 power. So I want the fifth root of 243. That's 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. So that's the same as 3 times 3, which is 9. Example B. 16 to the 3/2 power. I want the square root of 16, which is 4, and I want to use that as a factor 3 times. Right? So that's going to be 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. Right? You guys may want to try these 3 examples on your own, see how you do with them. Right? I'll write out the answers in a moment. Right? See how we do. We want the cube root of 512, of negative 512. So I want the cube root of negative 8 times negative 8 times negative 8. 8 times 8 is 64. 64 times 8 is 512. So the cube root of negative 512 is negative 8. Negative 64 to the 2/3 power. That's the same as negative 64 to the 1/3 times negative 64 to the 1/3. We want to take the cube root of 64. 4 times 4 is 16 times 4 is 64. That's going to be negative 4 times negative 4, which would be 16. 9 to the 5/2 power. That's the same as 9 to the 1/2 power, used as a factor 5 times. That's 9 to the 1/2 times 9 to the 1/2 times 9 to the 1/2 times 9 to the 1/2. 9 to the 1/2 is the square root of 9, which is 3. Times 3 times 3 times 3 times 3. 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. Then we have 256 to the 3/4 power. That's the same as 256 to the 1/4 power times 256 to the 1/4 power times 256 to the 1/4 power. So we want the fourth root of 256. 4 times 4 is 16, times 4 is 64. 64 times 4 is 256. That's the same as 4 times 4 times 4, which would be 64. So we want the fourth root of 256, which is 4, and we're using that as a factor 3 times. All right. Our next page here, we have the radius r of a sphere is given by the equation r is equal to 3 times v over 4 times pi raised to the 1/3 power, where v is the volume of the sphere. Find the radius of the beach ball to the nearest foot. Use 3.14 for pi. Right? So the radius is going to be equal to 3 times the volume. The volume you're given here is 113. So 3 times 113 over 4 times pi, and we're told to use 3.14 for pi. That's all raised to the 1/3 power. So we have to evaluate the inside of that parentheses first. So we do 3 times 13, 3 times 113 divided by 4 times 3.14. That gives us about 27, but that still has to be taken to the 1/3 power. So we want the cube root of 27. Cube root of 27 is going to be 3. So it's about 3 feet for that problem. Right. Then our last problem today is calculate the annual inflation rate, R, in decimal form of an item that increases in value from P to F over a period of n years. You can use the equation R is equal to F over P raised to the 1 over n minus 1. Find the annual inflation rate to the nearest 0.1% of a house that increases in value from 200,000 to 235,000 over a period of 5 years. All right, so how's that going to work? We use our formula. R is going to be equal to F over P. Well, if an increase in value from P to F, so our numerator is going to be the 235,000. Our denominator is going to be the 200,000. So that's F over P raised to the 1 over n, where n is the number of years, so that's 1 over 5. Then we have to take away 1. So R is going to be equal to, when I divide 235 by 200, that's going to give us 1.175. That's raised to the 1/5 power, and then we take away 1. When we take the 5th root of 1.175, that winds up being 1.032 but then we take away 1. So R is going to be equal to 0.0327779, but as a percent, we have to multiply that by 100. So that's about, the interest rate is about 3%. All right, so that's our lesson with powers. Hopefully that's been helpful, and we'll see you soon.